Hey everybody, how's everybody doing? Welcome to problem 4 out of 25 of our Power 25 series. Today we are doing binary tree level order traversal. So a quick overview of the Power 25. This is the 25 most essential problems to nailing those software interviews. It'll give you a great foundation kind of when combating these interviews, right? So let's get started. If you haven't watched my previous ones, I highly recommend those. So let's get started. So given a binary tree, return the level order traversal of its nodes values. So from left to right, level by level. For example, we have this binary tree, so 3, 9, 20, 15, 7. And we need to return this level by level. So you can see that level 1 is 3, level 2 is 9 and 20, and level 3 is 15 and 7. So it's sort of a level order traversal of this tree. So so you're saying, okay, it's very straightforward. It's like an implementation problem. But the problem arises because, right, remember when we have a binary tree, this isn't a binary search tree, this is a binary tree, so the values don't really matter, such as long as there's 2. You can only go left and right. So how are we going to keep track, right? Let's say that we have a kind of a crazy tree. I'm going to go over to this example. So this is kind of the example below. We have this crazy tree, and we can denote the dead values or the values right here. They don't have any null values, but we can devote the null values to x. And what we can kind of say is, okay, so we have this, right? We have this tree, and it's kind of hard. How are we going to keep track of this 2 down here, and then this? So this is going to return level 1 is going to be a 3. Level 2 is going to be a 9 and a 20. Level 3 is going to be an 8, a 15, and a 7. Level 4 is going to be a 14 and a 5. Level 5, and then level 5 is going to be a 2. So what data structure, what can we use to kind of solve this problem? A very intuitive and very essential kind of problem, a searching problem, is called breadth first search. Breadth first search, literally in the name, means to go by breadth or by level, which is exactly what we want for this tree level order traversal. What we're going to do is we're going to kind of go through all of these nodes level by level, and before we recurse deeper into these nodes, we want to kind of visit the children first. So depth first search goes by depth, right? So depth first search is going to keep going 3, and it's going to go to the 9. It's going to keep going, right, in a depth first search manner. The level is saying, hey, before we go to this 9 and 20, we're going to make, or before, let's say we have the 3, and then we have a 9 and 20. So before we go to the 8, right, so we're going to visit the 3, so that's a check. We're going to visit the 9, and we're going to say, okay, before we go to the 8, we need to make sure that the 20 is visited first, right? So like, same thing here, right? Like before we go to these null nodes here, we're gonna need to make sure that the 15 and the 7 is accounted for. So we're going level by level. We're not recursing deeper in until the nodes at the same level are accounted for. And what better way to use that than a queue, right? A queue, you can imagine that as kind of like a restaurant line, right? You're kind of in queue for an order. It follows a first in, first out mentality. So what do I mean by that? Let's append a 3 to the queue. So we have this queue. We're going to pop the value. So 3 is going to get popped. And we're going to say, okay, let's check if the 3 has children. The 3 does have children. That's great. First off, we have an output array. We're going to put the 3 here. So the 3 is going to have children. The 3 has a 9 and then a 20. So what we're going to do is, okay, it's going to have a left and a right. So we're going to append the 9, and then we're going to append a 20 to the queue. Very, very kind of trivial. So now let's go to the 9. Let's pop the 9. Okay, well, the 9, we're going to, right, after we iterated through the first kind of in level length of that queue, now we're going to go on to the next level. So we're iterating twice. So now the 9 is going to say, okay, we're going to pop the 9, we're going to append its current value. Does the 9 have any children? It does. It has 1 child. It has an 8, right? We're not going to append if this is none. So we're going to add an 8. Here. So that's great. And notice that we're not going to the 8 after that. We still need to account for this 20. And now we're going to pop the 20. So that's good and all. 20 is going to go here. Does the 20 have any children? Yes. The 20 has a 15 and a 7. So we're going to append a 15 and then a 7. Notice before we go to the 15 and 7, remember it's a breadth first search manner, so we want to go to the 8 first. Right? So then we append the 20. And now this level was completely iterated through. Now we do the same exact logic, right? And we have another level, right? This is the kind of end of the array. And we're going to pop the 8. So 8 is going to have no children, so we're not going to do anything. We're going to go to the 15. 15 is going to have 2 children, right? It's going to have a 14 and a 5. So we're popping the 15. And we're adding we add the 8 first, and then we add the 15. And then remember, before we go to the 14 and the 5, we're going to go to the 7. And we do the same exact process. The 7 is going to have no children, so we're just going to append the value, and we can proceed on. You can kind of see here, now we go to the 14 and the 5. The 14 is going to have one child. It's going to be the 2. So we're going to add the 2 to the queue, right? We're going to pop the 14 right first. And what we're going to do is say, okay, well, we have a 14. We're going to append the 14 here. Same thing with the 5, right? The 5 is not going to have any children. So we're going to kind of pop the 5, we're going to append it here, and very lastly, we get to the last thing of the queue, which is the 2. And the 2 is not going to have any children. Now we can do a check, right? The queue is now empty, so we're good to go, and our tree is totally explored and totally fine. And we're very much done, and we can return this output array that has all of our nodes level by level. And yeah, that's about it for the high-level walkthrough, and now I will take you guys through the coding implementation of this. Alright, cool. So now we're going to go and jump into the coding implementation of our tree level order traversal function. So we have this level order function defined here. We're going to take a root node, which is our kind of root tree node. So first we're going to do some basic checking. So if our root is none, we're just going to return an empty array, right? So that's kind of the case of, like, let's say we don't even have a tree, we don't even have a root, we always want to do that. Now, kind of how we did it in our high-level walkthrough, our total nodes is going to be an empty array, so this is kind of what's going to store all of our array. And now we're just going to say, okay, first off, we need to import kind of this thing in Python. It's basically a queue. It's called a dequeue, and we're going to use that as our queue. So our queue object is going to equal a dequeue, right? And what are we passing in? Well, inside of dequeue, we are passing in our root, right? So we're passing in this for our sort of root, and that's going to be our queue. And what is this saying, passing in the root? This is basically, let's say this example here, we're basically just initializing this queue with one value that is a 3. And remember, it's going to kind of do the iteration like we did before, because we're kicking off that iteration. So now we just need to keep checking, right? While the length of our queue is not equal to 0, so while there's still elements that are in the queue, the length of our level, right? So to know how many that we need to iterate through, right, is going to equal the length of the queue. So the first one, we know that we're going to iterate one time, because that's going to be the length of 3. When we add the 9 and the 20, right, now we know we need to iterate 2 times, so our level length will be 2, right? We need to kind of know how much we need to iterate that. So our level length is going to equal the length of the queue. Also, our level nodes is going to kind of be a list, right? We're going to be appending a list into this list, right? We're going to be appending the list of 3, then we're going to be appending the list of 9 and 20, the list of 8 and 15. So this is going to be the list that we're going to be appending to. And now we just need to add the values in this level nodes list. So we're going to say for I in range of our, what are we going to say? In the range of the length of the level, so the level length. So for I in range of the length of the level, what we're going to do, we're going to say our current node is basically just going to be equal to, right, we're just going to pop, this is basically just saying we're going to pop it from the queue. Our current node is going to equal to the queue.pop left, right? That's basically what we did of popping sort of this element here. So now we have that to work with, and we need to access the dot value of that, right? So we're going to say level nodes dot append, so we're appending to our level nodes array, the current node dot value, right? So we have the value here. Now we just need to check. So if our current node has a left child, right? Well, what do we know? We want to append the left child like how we did in the implementation to the queue, right? Also, right, if, you know, our current node also has a right child, we're just going to do the same exact thing, and we're just going to append the current node dot right. And at the very end of the day, your iteration should be done, and we should be able to return our total nodes. And let's see. Okay, so it seems like we got an error here. Oh, sorry about that. Forgot one last thing. So also at the very end, we need to do a total nodes dot append our level nodes, right? So for our 2D array, right, we need to append, let's say we have this 2D array, and we need to kind of put in, we need to append this list of 3, we need to append this list of 9 and 20, right? So we're kind of appending it, this kind of built array that we're building with these values to our, you know, total nodes. And at the very end of the day, when everything is built, we're going to return our total nodes, and let's see if this works. And awesome, this actually submits. Very good time and space. This is actually O of V plus E time, where V is the number of vertices and ease the number of edges. And if you're kind of not familiar with that, like I said, I'll go through a kind of whole other video explaining time and space complexity. And yeah, this is a very essential concept for breadth first search and kind of knowing how to traverse the tree in this kind of manner. But anyway, I hope you guys enjoyed, and I will see you in the next video. Thank you so much.